We used RSOM to image murine colitis and murine colitis-associated cancer. For this, we used well-established models of colitis using dextran sodium sulfate or a combination of X-oxymethane and DSS to induce colonic tumors. As shown in this 3D volume, you can observe a regular vascular structure in the mucosa of healthy tissue. In contrast, the tumor is marked by extensive intraluminal growth with irregular vasculature at the base. In the zoomed view, you can see how the vasculature is supplying the neoplastic tissue, which is growing outside the mucosa. Raster-Scanning Optoacoustic Mesoscopy also enables in vivo imaging. On the left, there's the colonic mucosa of a healthy mouse imaged transabdominally through the shaved skin of the animal. On the right, there's the inflamed colon marked by a prominent vasculature. These features are also easily visible in orthogonal projections from both healthy and inflamed mice. Or in a similar way when you move through the z-axis in a maximum intensity projection. This can quantitatively measure differences in healthy and diseased tissue as shown by an increased vessel diameter and increased blood volume in the inflammatory state. We then demonstrate that RSOM is able to detect exogenous absorbers such as labeling dyes in a model of adoptive T-cell transfer colitis. We splitted ultrasonic detection of the in vivo images of the colonic mucosa to low, high, and very high frequencies. Interestingly, it is then possible to visualize clusters of previously labeled T cells in the inflamed intestine in vivo. We were able to show that this signal is higher than in control healthy or in control acute colitis tissue. Multiphoton microscopy could nicely confirm our in vivo imaging results. This technology is not available as an approved endoscopic device. Current research systems are limited by penetration depth, single wavelength illumination, and acquisition times. However, despite limitations, it holds great perspective for preclinical applications in the future. And it might play a role in gastrointestinal imaging if the technology could be implemented into an endoscopic device. For RSOM, it has not been achieved yet. In comparison to others, RSOM might be helpful to solve different questions concerning whole intestinal wall assessments better than other existing or future technologies. Through an EU-funded project EsoTrack, RSOM is converted into an endoscopic device and therefore it could be a valuable instrument to visualize whole wall inflammation in inflammatory bowel disease or the depth of suspect lesions in tumor diagnostics.